Hey guys, we're going to do a video for 10-3 homework, so let's do it. They start on 14 and go through 33. So question 14 states, what is Ashton's error? So we're solving TS this length, and they end up getting the answer 8. Okay, well we see there's a right triangle here, and we learned today that this is the perpendicular bisector, right? So this chord PR got cut in half. So if that's 6, then this distance is 6. And TS is what we're solving for. So if I call that X, I can solve for X by using the Pythagorean theorem. All right. So we get A squared is 6 squared. Squared is x squared. So if you look at what Ashton did, it looks like it's interesting. He took 12 squared minus 9 squared. So if we kind of lay it out the same way he did, I can subtract 9 squared. So x squared equals 9 squared minus 6 squared. See what he did there? He ended up taking PR, the whole distance, and that's not our right triangle. So what was his mistake? He needed to plug in PS, not PR. And this would have given him the length TS. So let's finish this out. I want the square root of this. So that would be the square root of 50, 40, 45. So the square root of 45 is about 6.7. Okay, and that number makes a little bit more sense, I think, based on our drawing. Number 18. So some of the classes we did this. Let me walk back through my thinking here. So given VBT is 90, and arc PR is 90 degrees of arc. So we know if the arc is 90 degrees, then the central angle is 90 degrees. And given that QR is equal to TU, so given QR, this chord is equal to TU, that chord, what conclusions can be made? So first they're asking us to find what's the measure of PBR. PBR. Okay, we already found that, 90. What's the measure of TV? Okay. This arc, we could say, is 90 degrees. Right? And that's 90 degrees of arc because the central angle is 90. Which angle is congruent to, oh, it looks like I already wrote that in, to QBR. So QBR, that would have to be equal to that, and that is our theorem 10-3. So today we said if these are congruent, then their angles happen to be congruent because they're congruent triangles. So this angle QBR has to equal this angle TBU. Oh, and I didn't even have to do number 20. I got ahead of myself. Okay. Question number 21. Which segment is congruent to TV? So TV, this segment would have to equal this segment, right? And again, that's that converse theorem. So TV would be congruent to PR. Question 22. It says, construct a square inside of a circle. How is drawing that square different than drawing a hexagon or triangle? So in class today, depending on how long you were in there, we drew an equilateral triangle and a hexagon inside a circle. And we noticed that this was different. All I did here was kind of copy the radius. To construct a square inside of a circle was very different. We made a circle, And then we made a radius. And then we used our steps for the perpendicular bisector to find the new coordinates E and F that would allow us to make a square. So these steps are quite different. These two constructions are very different. So it says, how is these drawings different? Well, drawing a square inside a circle required us to use the steps for perpendicular bisector. While the equilateral triangle was just steps copying the radius multiple times. So very different steps. Now looking at 23, it states, what would CD be? Well, we learned that if this distance 6 is equal to this distance 6, then these chords have to be equal. This was theorem, I believe it was theorem 10.5 or 10.6. So if this is 15 because this is a perpendicular bisector, which means the whole distance CD would be 15 plus 15, or 30. Okay, question number 25. A chord is 12 centimeters long. It's 30 centimeters from the center of the circle. Okay, so it looks like we have a circle. It's 30 centimeters. Okay, that's 30 centimeters from the center. And the chord is 12. So I actually maybe should go even further than that. So the chord is actually quite a bit shorter than the distance there. So this is 12. AB is 12. And this distance is 30. What is the radius of this circle? Okay, so we can draw in a radius, and we know that's a perpendicular bisector. So if this whole thing is 12, this is 6, right? And we can solve for the radius. So we'll call that A, and we'll call 30, we'll call B, and the radius we can call C. Okay, so calculating, what is the square root of 936? 30.6. Okay, and that number makes sense. So a radius of 30.6 centimeters would be the hypotenuse of a triangle that's 30 by 6. Question number 27. A chord is 4 units from the center. The radius is 5 units from the center. Okay, so drawing our circle. Our radius is 5. Okay. Our chord is 4 from the center. So that would mean this would be a picture of our chord. So this distance is 4. The whole distance is 5. And we know a bunch of other stuff is 5, right? Because that would mean this would be 5. This would be 5. So this distance is 4. That's a perpendicular bisector. So the chord is 4 units from the center. What is the length of the chord? So what is AB? Well, we can't directly solve that, but we could solve this and then double it. So let's solve for x. right? And this is our most famous triangle of all time. This is equal to 9. X is equal to the square root of 9 or 3. So this is a 3, 4, 5 triangle, which means AB would be 3 plus another 3, which makes 6 units long. Almost done. So the last two problems here, 25, 26, 27, 25, 26, 27. Yeah, okay. Two more. What must be true? Select all that apply. So we know when things are trapped inside circles, lots of things are congruent. So let's collect up some congruent items. QR, this arc is equal to this arc. That would be yes. Based on our theorem, if the arcs are equal, then the chords are equal and vice versa. Would PR equal to TV? Would PR equal to TV? Yes, because they're the same distance from the center. So that was another one of our theorems. Would VW, half of our chord, be equal to AS? That's going to be no. Those are two different things. So I'm not going to pick that. They could be equal, but we don't know that. Would PS equal to SR? Would PS equal to SR? Yes, because those are perpendicular bisectors. And last, would PR, arc PR, be congruent to TV? Yes, because these chords are equal because they're the same distance, and if the chords are equal, then the arcs are equal. Yes. Last one, the radius of a semicircle is R. And CD, this chord, is 3/4 times AB. So CD is 3/4. And what is AB? Well, AB is R plus R or 2R. What is the distance from the chord to the diameter? So what is this? We'll call it X. I see a right triangle. I also see this right triangle, right? So that's my radius from the center to my edge. I got to solve for X, but I know this distance already is just half of CD, so it's half of this. So 3/4 times another half. So that distance, we can call that Y, is 3/4 R. All right, so now we can plug this in. We'll call that A, we'll call that B, and we'll call that C. So I'm going to distribute the exponent. And this would look like this. And then I'm going to solve for X, right? So I can subtract R squared from both sides. So X squared is equal to 9/16 R squared minus another 1 R squared, or 16/16 R squared. Uh-oh, I messed this up, guys. I messed up my A, my B, and my C. Now look here. Oh, look at what I did here. This is my hypotenuse, so that's got to be C. Oops. Let's try that over again. Y. 3/4 r squared. Yeah, this looks better. Now you might be like, well, how did you know you messed up? I was getting a negative length. So it's like, oh wait, that's not gonna work. So we're going to subtract 9/16 r squared on both sides. And we get 16/16 r squared minus 9/16 r squared will give me 7/16 r squared. I'm almost there. Now, that's x squared, but I got to take the square root to get my final answer. So the square root of 7 over the square root of 16 and the square root of r squared. So we get the square root of 7 over 4r. Let's look for our answer. The square root of 7 over 4r. We've done it. Nice work, guys. See you next time.